ASAP now allows the geometric prescription from IGES, CATPart, or GTX files to be modeled as exact Bézier patches without the need for preconditioning of the CAD files outside of ASAP. We want to demonstrate the new geometry conditioner feature using a higher order surface, higher order asymmetric surface that we've constructed in the CATIA V5 R19 environment. As we look at the sort of oddly shaped surface and rotate it around, we can note that there are a number of third order or higher inflection points around the surface. And we've done this intentionally in order to demonstrate the new import capability in ASAP. So we've saved this file as a CATPart file, and we'll now bring that in directly into the ASAP environment. Now in ASAP, we can open our save surface and immediately see that two new options have been added to our CATIA setup parameters window: condition geometry and rebuild surface. Now, the condition geometry option translates the imported surface as an accurate higher order Bézier patch surface rather than a simpler lofted surface. And we see that we can define either automatic or user-defined tolerances for the translation, and those tolerances are specified in system units. Now, let's see what we mean by higher order Bézier patches. We'll choose just the condition geometry option, and we will finish the translation process. And if we look at the resulting INR file, we can see that we have a number of curves that are then constructed into a set of third order Bézier patches. Now we're going to run the file, and we'll look first at the edges associated with the patches that we've created. And then we're going to overlay a faceted view of the surface itself, and we'll look at that in the 3D window. And we can now see the grid structure of the patches themselves as well as the surface. And these patches now accurately reconstruct the entire original surface that we created in CATIA. Now, let's repeat the translation process using the rebuild surface option instead. And this option actually lets us choose the order of the surfaces that we want to create in both our U and V parametric space directions. And again, we can define a maximum tolerance in system units for the rebuilt surface, and the Bézier patches will be constructed to the accuracy that we want. So we'll click OK, and we will again finish the translation process. Now we note that in this INR file, we again have a series of curves that have been constructed into a set of second order Bézier patches. And we'll run this file, and we'll render the surface exactly as we did previously. First with our grid of patches, and then with the overlay of the patch surface. Now, we'll notice that the faceting takes a little bit longer because we have a higher number of patches that have been constructed as second order. And we can now look at that in the 3D viewer window. And again, we see our grid of patches overlaid by the surface itself. And we can compare that directly to the third order surface that we previously constructed. Now, since the second order surface resulted in a higher number of patches, we might ask then, what is the advantage of using a second order Bézier surface? Well, if we do a quick ray trace on our third order surface, In this case, we're only tracing about 10,000 rays. We can note in the output window that for 10,000 rays, we took about 6 seconds of CPU time. We can repeat that ray trace for the second order surface. And again, the faceting takes a little bit longer because of the higher number of patches. But we can see that we only took a little less than 3 seconds of CPU time. So we can see immediately the ray tracing speed advantages for importing higher order or freeform type surfaces from a variety of CAD programs as second order Bézier patches into the ASAP environment.